And here comes part 2. So type 4 is calculating equilibrium concentrations, part 2. So the difference with this one is that the question is going to ask you for the equilibrium concentrations of all your species, and what they're going to give you is initial and KEQ. So in part 1, they gave you initial and one of your equilibrium concentrations, whereas here they're going to give you initial and KEQ. You won't know any of your equilibrium concentrations. So the key idea here is that no species has both initial and equilibrium values. Unfortunately, this means that algebra is going to be required, but we're going to use as easy as algebra as we can. Again, there's some rough estimates of steps here, and I finally gave a question where I didn't draw the rice chart for you, just so you can see how I would draw these rice charts if I was doing them. So the key thing here is that you're going to make a rice chart because you don't know everything at equilibrium. They're going to give you things at initial concentrations. So let's start off with that. So I'm going to go R, I, C, and E. And then I go across. I don't write what they are. I just put those letters. And then I put a line across. And then what I like to do is look at, what do I have? So I have 2 reactants, and I don't put little like mini lines in between. I just go like this, but then I put a double line between my reactants and my products. So this is my hydrogen, this is my iodine, and I'm producing 2 hydroiodic gases. Okay, so that's what my rice chart looks like, and then I'm going to figure out from here. So the next thing we're going to do is write equilibrium expressions or concentrations as expressions of X. So I've skipped a bunch of stuff in there because we've already done type 1. So what's going to happen is they're going to give us initial concentrations. So they've given us the initial concentration of hydrogen and iodine, which means that I have no product to start with. We know that these are going to change according to their molemolar ratios. So because I'm starting with hydrogen and iodine, these are both going to go down, and then I'm going to produce. Now for my molemolar ratio, these are going to go down by 1x, and this is going to go up by 2x. Because they're not going to give me the equilibrium concentrations, I'm going to go ahead and put my expressions in here. So 0.200 minus x, 0.200 minus x, and there's a reason they start them with the same concentrations, which I'll show you in a sec. And then this one is 0 plus 2x, or just a 2x. So the biggest difference between type 3 and type 4 is you're not getting any equilibrium concentrations. You won't know x until we do a bunch of algebra. But what they have given me is KEQ. So for this line, we know the ratio of products to reactants is 25. So let's try these. My KEQ expression. Let's look at the steps. I can't remember what I wrote. So the next thing I'm going to do is write the KEQ expression and then substitute the expressions into the equation and algebraically solve for x. So here we go. KEQ is equal to HI squared divided by hydrogen and iodine. Okay. So my KEQ value is 25. My concentration of hydrogen is 2x, and that's going to get squared. My concentration of hydrogen is 0.200 minus x, and my concentration of iodine is also 0.200 minus x. Coinky dinky. Let's write that as squared. Let's say 25 is equal to 2x all squared divided by 0.200 minus x all squared. So this is Chemistry 60, not Math 60. And so what they do is they try to set these questions up that you can understand how to solve these questions, but they try to make the algebra simple. What you'll notice is that this whole entire right side is squared. So you could get rid of those squared values by taking the square root. And you're allowed to do that because the square root or the power rule states that as long as you raise one side to the same exponent as the other side, you're allowed to do it. And you'll notice I started this question with a KEQ that's a perfect square. We're going to warm up into the algebra here. So we're going to do, kind of layer up in difficulty. So for these questions, for type 4, first of all, you'll notice on the right-hand side, everything is squared. Now that's not going to change. But I'm starting you off with the left-hand side being a perfect square so that we can take off that square root sign and say that 5.00 is equal to 2x, because the square root of 2x all squared is just 2x, over 0.200 minus x, right? Much easier algebra. Now, keep following, because this is something that everybody struggles with even in Math 60, is that now we need to solve for the x. Let's get it out of the denominator by multiplying both sides by 0.200 minus x. We would end up with 5 times 0.200 minus x is equal to 2x. Now, a lot of people are like, well, let's divide. I'm like, well, then you'd get back to where you were before. I'm going to tell you what you have to do next, which is multiply through. You're going to end up with 5 times 0.2, which gives me 1. And we'll just keep track of our sig fig. So that's 1, well, let's do it. So 1.00 minus the 5.00x is equal to 2x. And that 2 wouldn't have any sig figs attached to it because it's a change. Then you're going to put your x's on the same side. So you're going to get 1.00 is equal to 2x plus 5.00x. So I've taken this and I've added the 5.00x to both sides. So then I end up with 1.00 equal to 7.00x. And then I'm going to divide both sides by 7. I end up with x equals 1 divided by 7, and I've kept track of my sig figs, so I'm going to answer as 0.1428 ... but I'm going to keep, actually, you know what I'll do? This is what I like to do. So we're not at a final answer yet, so I'm going to keep track of my sig figs by writing 0.142 ... So 2 would get rounded, but I'm not writing it down as a final answer. I'm just keeping track of my sig figs. And then what we want to know is the equilibrium concentration of the hydrogen, the iodine, and the HI. So the hydrogen concentration is going to equal the iodine concentration. And they're both going to be 0.200 minus 0.142. So I'm going to store this in my calculator so I don't have to keep typing it. So I'm going to put 0.2 minus, recall A. Now I'm going to answer to 3 decimal places, so 0.057 molar. Then I'm going to do the same thing with my hydriodic gas. And it's going to be equal to 2x. So it's going to be 2 times that recall A, or that 0.142 ... So I've got 2 times recall A. And again, I'm going to answer to 3 decimal places, or 3 sig figs, I should say. So I'm going to put 0.286 molar. So my answers have a different number of sig figs, but that's because my last operation was a subtraction. So my answer would be 0.057 as my concentration of hydrogen and iodine, which the question didn't even ask you for, but I just thought I'd show you. And what they really wanted to know was my concentration of HI. Okay, so I've done more work than I needed to in that question, but my final answer would be the concentration of HI is 0.286. Okay, so I've got another question here where again, I've made the equilibrium constant a perfect square. So I want you to pause the video and I want you to try this one. And then what we'll do is we'll build up to doing the ones where it's not a perfect square. So for this one, my reaction is sulfur dioxide, nitrogen dioxide, forming sulfur trioxide, and nitrogen monoxide. 4 moles of SO2 and 4 moles of nitrogen dioxide are placed in a 5-liter container. So my concentration of SO2 and my concentration of NO2 to start is going to be 4.0 divided by 5.0, which is 0.80. So my initial concentration of sulfur dioxide is 0.80. My initial concentration of nitrogen dioxide is also 0.80, which means that I'm starting with no sulfur trioxide and no nitrogen monoxide. Okay, Then we want to figure out our change line. Now, this one, they gave us a balanced equation. Really, anytime they write down an equation, I'm going to assume it's balanced, but because there's no coefficients, I always like to check. So 2 oxygens make 4, 3 and 1 make 4, 1 nitrogen, 1 sulfur. We're good. So how is this going to change? Well, it's going to change in a 1-to-1 ratio. My reactants are going to decrease, and my products are going to increase. So my equilibrium concentration will be 0.80 minus X for both of these. And then both of these will be X. So you'll notice these questions are setting you up for easy algebra. Now let's write the KEQ expression. Concentration of sulfur trioxide, concentration of nitrogen monoxide, divided by sulfur dioxide and nitrogen dioxide. They've given us that the KEQ value was 0.36, and that's going to equal X times X over 0.80 minus X, 0.80 minus X. Now, personally, I would have jumped straight to 0.36 is equal to X squared divided by 0.80 minus X squared. And again, these questions will always be set up this way so that you can take the square root. So then the square root of 0.36, I think it's 0.06, but let's check. Yeah, is going to be 0.6. Let's keep track of sig figs, so let's say 0.60 is going to equal X over 0.80 minus X. Now, if you've just been watching the video, maybe now you should pause. It is really good to struggle through and think, what's next? What's next? Because if I keep doing it for you, you're going to be like, oh, that's easy. But you have to be able to do it on your own in your homework. What do I do from here? Trying to get X by itself. I have an X in the numerator and I have an X in the denominator. Where do I go? No, I can't divide. What do I do? Hopefully you're looking at the previous page right now and thinking, oh, she multiplied both sides by 0.80 minus X. Then I multiplied through. So 0.8 times 0.6 is going to give me 0.48 minus 0.60x is equal to X. Now what? Well, now I want to get the X's on one side, so I get 0.48 is equal to X plus 0.60x. And again, this is a 1, but it's not counted as precision or sig figs because it's a mole-to-mole ratio that's exact. So I'm going to say that this is 0.48 is equal to 1.60x. So now I can divide by 1.6. Which gives me X is 0.30. Now I'm actually going to pay attention to this question this time. And now this says, what are the concentrations of all species? So the concentration of my sulfur dioxide is going to equal my concentration of nitrogen dioxide. And it's going to be equal to 0.80 minus X. So 0.80 minus the 0.30, which is going to be 0.50 molar. And then my concentration of sulfur trioxide is going to equal my concentration of nitrogen monoxide, which is going to be just X, which is 0.30 molar. And those are my answers. So what I'm going to say is I think I'm actually going to split this into 2 videos, even though I originally hadn't made it that way, because I want you to go and practice the ones that have these perfect square KEQs. So go and practice these, and then we're going to up it a level to where the KEQ is not a perfect square.